Okay, so we can use our probability density functions to find the mode of the data. So remember, the mode it's the most popular thing. So it's actually where our graph is right up here. If we were doing discrete data and we had a histogram, then there's our mode. The highest column is the mode. In this case, it's the point where the graph is at its highest. So it's a maximum turning point. So in this particular one, our mode is where x equals 5. Okay, we don't need to know the y coordinate. We only need to find the x coordinate. We do need it to be a maximum and not a minimum. Okay, the most common score. So the mode there is 5. So here's an example. A probability distribution function is given by this equation here on the domain from 3 to 7. Find the mode of the data. So first of all, to note, it is a parabola. It is concave down. So because of that, it does have a maximum. I think in this case that's enough of a proof that it is a maximum and not a minimum. Now there's two ways to find that x value. There is a formula for finding that that was in the old course that's been taken out of yours, that it's negative b on 2a. That actually gives you that turning point. And that's when a parabola is written in this form, plus bx plus c equals, in this case it's equals y, isn't it? I'll put y equals. So if you put x equals negative b on 2a, you actually get that value for a parabola. But I'm going to do it using calculus because it's not always going to be a parabola. Okay, so first of all, f of x, I'm going to expand that out. I could differentiate it because that's what I need to do to find a maximum. I need to differentiate and make it equal to 0. So I could use the product rule and do that, but it's much easier if I just expand it out. So 3 9s are 27x over 224 minus 3x times x is 3x squared over 224. There's my parabola. So my a is negative 3 on 224, if I'm going to use this formula, and my b is 27 on 224. So your a is your coefficient of your x squared, your b is your coefficient of your x. So you could literally put it into that formula if you wanted to. I'm not going to, as I said. So I'm going to differentiate and make it equal to 0. So it's a pretty simple derivative. That's just 27 on 224. I know we've been integrating a lot recently. It's very easy to get the two confused, so just be a bit careful there. Minus, multiply by the 2, 6x on 224. And we want to know where does that equal 0. So 0 equals 27 on 224 minus 6x on 224. First thing I'm going to do there is multiply everything by 224. Okay, each side of the equation. So this side is still 0. This times 224 is 27 minus 6x. So that's nice and easy. I've multiplied both by 224. I'm going to add the 6x. So plus a 6x there, plus a 6x there. Simple year 7 equation solving. So 6x equals 27. Okay, divide by the 6. So 27 on 6, that simplifies by 3, so 9 on 2. So 4.5 is where our mode is. Our mode equals 4.5. If it was another function, and if we got more than one stationary point, we do of course need to find where it's a maximum. Now there is one other thing that's worth noting here. This particular function, it looks like that. That's 9. Okay, this is 0. And we're defined on the domain from 3 to 7. So 3 to 7. And this mode was on that domain. If you got one that wasn't, let's say we were defined from 5 to 7 only. Okay, so if we had a function with this curve defined from 5 to 7 and the maximum was not in there, then the mode would be this point here. Okay, the mode would be it's an absolute maximum on our domain rather than a relative local maximum. So in this particular case, the mode would be 5.